Hello and welcome to this lesson about the volumes of cylinders, cones, and pyramids. The learning target for this video is to learn how to use some formulas to find, too many twos there, to find volumes. So first, let's get into a core idea. Volume is going to be equal to base area, that's what that BA stands for, times height. Now, when we're looking at cylinders, this becomes a lot more obvious. And then as we go up to cones and pyramids, the concept is still very much there. And then as we, even further down the road, look at more unconventional shapes, if we just understand that we have the base area of something, and we can then multiply by its height, we've found the volume. So remember, volume is equal to a base area times its height. So let's talk about cylinders. Cylinders, essentially, I want you to think of like a soda can or a canned food where you have a cylinder that looks like that right there. Now, we're going to apply this idea of volume is equal to the base area times the height. Well, let's look at what the base area is. The base area is just this circle. And what we're doing is we're wondering how many circles there are in this cylinder. Like how many we could kind of stack up on top of each other, and that gets to how much space the whole cylinder is taking. So if we could find the area of that'd be great. And since it's a circle, it's just going to be equal to pi r squared. And then we're just going to have to multiply by its height. Now, just to kind of show you a slightly different look, sometimes, I'm not the best artist, so don't make fun of me for this. If it's on its side, like if it's knocked down, it could look something like this right here. Same idea. Perhaps you wouldn't call this height, you would call it depth. But as long as we know the area of this, we can figure out the rest. And so here, our volume formula for all of this is going to be equal to pi r squared times h. So let's do some examples. So let's say we have a cylinder. Again, I'm not the best artist, so bear with me there. And let's say that its radius is equal to 5, and that the height of the whole thing is equal to 12. So we use our formula. Volume is equal to pi r squared times our height. And so V equals pi, in parentheses, 5 squared times 12. Now, only the 5's being squared here. So what we're looking at is 5 times 5, which is 25, times pi times 12. All right, so what I'll do is I'm going to multiply 12 and 25 together first. That gives me 300 times by pi. And usually we just like to use 3.14 for pi, which is totally fine. So 300 times 3.14 ends up giving us 942 units cubed. Now we're talking about volume, so it's got to be units cubed. Okay, so take a second, process that. Let's do a couple more examples. So let's do one. We have another cylinder, but this time we're told that the diameter of the circle is equal to 12 and that its height is equal to 4. Now, probably not drawing the scale here, but nonetheless we can use these numbers, and we'll just use this to kind of help us envision what's going on. Now, diameter, that means how far it's going from end to end. So that right there is 12, meaning that the radius is 6. So if diameter is equal to 12, that means r is equal to 6. And we just apply everything we just did. So pi r squared times height, that's equal to pi times 6 squared times 4, which is then going to be equal to 36 times pi times 4. So you have 36 times pi, 36 times 4 is going to be 144. So 144 times by pi, using 3.14. Our final answer here, the volume is equal to 452.16 units cubed. And so that's how we use the formula to find the volume of a cylinder. Now let's talk about cones. So cones have a circular base, but then they come up to a point. Now what makes life a lot easier for us is knowing the formula. V is equal to 1/3 pi r squared h. So essentially we're taking this cylinder formula and we're just timesing it by 1/3. Now the big thing we got to do is just make sure that we watch our order of operations. So for example, if we had a cone and its dimensions were, let's just say 3 and 10, let's see what happens. All right, so volume would equal 1/3 pi 3 squared times 10. And so that's going to give us, now be careful, like a lot of you might see this 1/3 and 3 and start canceling things out. Don't. 1/3, because you have to do exponents first, pi times 9 times 10. Now if we want to, we can start mixing the numbers. So 1/3 times 9 goes away, becomes a 3. And so we're looking at pi times 30. You multiply that by 3.14, or 30 times 3.14. And we end up getting the volume is equal to 94.2 units cubed. So the only difference with cones is that we have to multiply by 1/3 at the very end. All right. Pyramids, guess what? It's the same thing. However, with a pyramid, we're going to just write it a little bit different. So we're going to say volume is equal to 1/3 base area times height. Now the reason why I want to go with base area is that we have two different types of pyramids we could work with. All right, so bear with my drawing right here. We could have, oh gosh, this is going to be awkward. They're actually not that bad. All right, it was kind of bad. Okay, we're going to have one with a rectangular or square base, and then we also have pyramids with, let me try like this, triangle bases. Now either way, it's the same formula, but what helps us is understanding that it's the base area. So for here, we'll just do length times width, and then we're still going to times it by its overall height. Down here, we have to be able to find 1/2 base times height, and then we're going to multiply that by, and sometimes we use like a big H to represent the height of the overall pyramid. So again, if we can just find the base area, times it by the height, we're good to go. So let's do two quick examples. Alright, so I paused the video so I could draw them well. So let's do the one on the left first. So here we have a square or a rectangular base that's 8 by 9. So its area is going to be 72. So what we're going to do, volume is equal to base area times height. We're going to go with V equals 72 times 15. 72 times 15 is 1,080, and that'll be units cubed. Now, talking about this one over here, the triangular prism, here we have our base is a triangle, and we're given some information. This 6 points to this part right here, which is giving us the height, and then we have the base. So the area of the triangle is 1/2, 10 times 6, which is 60 times by 1/2 is 30. And so our volume is base area times height. That's going to be 30 times 12, which is 360. Oh, whoa, sorry, 1 second here. 360 units cubed. Now, I just realized I cut a corner and totally forgot a step. 1/3. 1/3. So what I need to do is take this final area and I need to cut it or divide it by 1/3. So I'll take 1,080, divide by 3, and here I actually get this one to be 360 units cubed. Good thing I caught that. And then take this one, divide by 3, and I get 120 units cubed. So super important. We write down the formula correctly. I just learned that lesson. And then after that, it's about applying the formula. So that's how we find the volume for these different shapes. Again, it all hinges on the core idea that volume is equal to base area times height. And then depending on what shape we have, we might have to do a tweak or two to it. But I mean, it's just sort of a plug and chug. So good luck with your homework or practice, and let me know if you have any questions.